for 5 seconds. Earth stops spinning, you do not, right now, without knowing it. You are moving eastward. At the equator, that speed is roughly 1,600 kilometers per hour. At mid-latitudes, closer to 1,000. At the poles, almost nothing but moving. Always moving. Every second of your life, and the moment Earth stops. That movement does not stop with it. The oceans do not stop. The atmosphere does not stop. Every building, every tree, every person still moving. In a world that just decided to stay still, what happens in those 5 seconds is not just a disaster, it is physics doing something to a rotating planet that has never happened in 4.5 billion years, and the strangest part is not what happens when Earth stops. It is what happens. When Earth starts again, stay with me, because this one ends somewhere you will not see coming. Welcome to the IFs, where impossible scenarios meet real science. This one gets genuinely strange. Let us go. What you need to understand first. Before we talk about what stops, we need to talk about what keeps going. This single idea is the entire key to understanding everything that follows. When Earth stops spinning, Earth stops, but you do not. Neither does the ocean, neither does the atmosphere, neither does anything sitting on the surface of this planet that is not fused directly to the bedrock beneath it. This is inertia, and inertia has no interest in being reasonable about it. Think about what happens when a car brakes hard and suddenly, everything inside lurches forward. Your coffee slides toward the dashboard. Your phone launches toward the windscreen. Now scale that up. The car is an entire planet, and everything inside it is not a coffee cup. It is the Pacific Ocean, the Atlantic, every lake, every river, every drop of water sitting on the surface of Earth. Take 5 seconds and picture the street you live on right now, at the equator. Everything on that street is moving eastward at around 1,600 kilometers per hour relative to a suddenly stationary ground. At mid-latitudes, like most of Europe, most of the United States, most of Australia, that speed is closer to 1,000 to 1,200 kilometers per hour depending on where exactly you are. At the poles, almost nothing. The tips of the planet barely move at all as Earth rotates. This difference matters enormously because 5 seconds of stopped Earth does not feel the same in Singapore as it does in Oslo, or in Reykjavik, or at the South Pole. And that difference is what turns this from a simple disaster story into something genuinely fascinating. Let me show you through 3 people. Amara is standing outside her home in Nairobi, right on the equator, the highest rotational velocity on the planet. James is in his office on the 14th floor in London. Mid-latitude, significantly less rotational velocity than Amara, but far from safe. And then there is Sigrid, collecting eggs on her farm in rural Iceland, close enough to the poles that Earth barely moves beneath her feet at all. Remember these 3, because their stories are about to go in very different directions. Among the first things to respond are the oceans, not because they are weakest, but because water has no anchor, no roots, no foundation bolted to rock. When Earth stops, the oceans retain their angular momentum. They keep moving in the direction Earth was spinning. The result is violent relative motion between the water and the ocean floor beneath it. Now here is what most versions of this scenario get wrong. The ocean does not simply become a uniform wall of water racing east at the same speed everywhere. Simultaneously, the actual response is far more complex. And honestly, far more interesting. The effect depends on local ocean depth, coastline geometry, continental shelf shape, and the precise geography of each location. In deep open ocean, the effects are dramatic, but different from shallow coastal waters funneled into narrow bays. What is consistent across every ocean on the planet is this: violent relative motion between water and seafloor, generating displacement events on coastlines exposed to the direction of retained water movement. Some of those coastlines experience something catastrophic. Others experience something severe but survivable. The physics is real and violent, but not uniformly identical across every stretch of coastline on Earth. Amara in Nairobi is nowhere near the coast, but the Indian Ocean to her east is already responding to the same event. James in London, further from the equator. The North Atlantic responds differently. Less rotational velocity retained. Different coastline geometry. The effect is severe. but not the same as what hits equatorial coastlines. Sigrid in Iceland barely notices what the ocean does. The North Atlantic near her latitude was moving so slowly to begin with that the retained momentum is comparatively small. 3 people, 3 oceans, 3 completely different experiences of the same 5-second. The atmosphere also has angular momentum, and it also keeps moving when Earth stops. The critical word here is relative. The wind you experience is not simply air suddenly moving at 1,600 kilometers per hour past a stationary you. It is the relative difference between how fast the air above you is still moving and how fast the ground beneath you has stopped. At the equator, that difference is enormous. Amara experiences wind conditions stronger than anything in recorded human history. The relative motion between the stationary ground and the still-moving atmosphere creates forces no structure built by humans at ground level was designed to survive. At mid-latitudes, James experiences something severe, something unprecedented, strong enough to collapse structures, strong enough to turn debris into projectiles, but categorically different from what Amara is experiencing. Sigrid in Iceland feels a powerful and disorienting wind, stronger than any storm she has ever experienced, but survivable if she gets inside quickly enough. Same event, same 5 seconds. 3 completely different experiences defined entirely by one variable: how fast the ground beneath each person was moving before Earth stopped. The regions closest to the equator are where the rotational velocity and therefore the relative motion between ground and atmosphere is greatest. And those regions happen to be where a very large proportion of the world population lives. Physics does not consult a population map, but if it did, it would have chosen the worst possible places to concentrate its consequences. Now something below the surface that most discussions ignore. Earth is not a simple solid ball. It has a liquid outer core, a mantle, and a relatively thin crust sitting on top. Earth rotation contributes to its shape. Earth bulges slightly at the equator because of the spin. A sudden stop introduces new stresses into a crust that formed around a rotating planet over billions of years. The honest answer from geology is that the exact consequences are complex and model-dependent. Whether this triggers fault ruptures, which ones, on what timescale, is genuinely uncertain. What is not uncertain is this: you are introducing a stress event into a geological system that has been in dynamic balance for 4.5 billion years. The geology does not need to rupture everywhere simultaneously to make this terrifying. It just needs to be unpredictable. And it would be. 5 seconds pass. Earth begins spinning again, and this is where the scenario delivers its most surprising consequence. The viewer naturally thinks, the 5 seconds are over. The disaster is done. Wrong, because now the situation has reversed. The atmosphere and the oceans have been moving relative to a stopped Earth for 5 seconds. Now, Earth is moving again, and the atmosphere and the oceans have not yet caught up how quickly they do. And what that transition looks like in different locations is something our models can describe only in broad terms. The physics is real. The relative motion is real. But the precise sequence of events as everything adjusts back toward equilibrium would depend on the same variables that define the initial stop: latitude, ocean depth, local geography, atmospheric conditions at that exact moment. What we can say is this: the relative motion that created extreme wind events in one direction now shifts as Earth accelerates back beneath a still partially displaced atmosphere and ocean. This is not a second disaster, identical to the first. It is a transitional event, where every disturbed system is now interacting with a moving planet before it has recovered from the stop. Multiple disturbed systems, all responding to a moving planet, at different rates, in different directions. Before any of them have recovered from the first event, Amara is on the ground. Whether she survived the first 5 seconds depends on what was around her, the shelter available, the specific local effects if she did. The second phase arrives before the first is finished. James in London. If his building held through the first event, the secondary atmospheric shift rattles the structure again, differently, from a different direction. If Sigrid in Iceland got inside in time, she looks out her window at a sky that has gone from strange to stranger. In the space of 10 seconds, nobody, fully understands what they are seeing yet. The models do not give us a clean answer for what those 10 seconds look like in detail, and that uncertainty is in some ways more unsettling than any specific disaster would be. Let us zoom all the way out. Forget individual streets. Forget individual cities. What does Earth look like after 5 seconds of stopped spin followed by 5 seconds of resumed spin? The answer is defined almost entirely by one variable: latitude. The equatorial band, the region where rotational velocity was highest, has experienced the most extreme relative wind events, the largest ocean displacement events, the most significant geological stress introduction, and the most complex secondary phase as Earth resumed spinning. Survival in this region during those 10 seconds depends on underground shelter, reinforced structures far from coastlines and known geological risk zones, local geography that reduced rather than amplified the effects, and a great deal of chance. The mid-latitudes, London, New York, Tokyo, Sydney, Berlin, experienced something severe and unprecedented. Survivable for some, not for others, depending on shelter, location, and the specific local expression of events that were never identical twice. The polar regions experienced something closer to a very large storm combined with unusual geological activity. Dramatic, but comparatively manageable. Amara, James, Sigrid, 3 people. Same 5 seconds. 3 completely different worlds to navigate. Whether each of them is there to navigate, it all depends on variables the science cannot fully resolve. And here is the thought that genuinely stopped me when researching this. The most isolated, the coldest, the most apparently inhospitable places on Earth turn out to be the most protected, not the cities, not the infrastructure, not everything modern civilization built to be resilient. The empty regions closest to the poles, where the ground was barely moving to begin with. So, what if Earth stopped spinning for 5 seconds? Amara at the equator faces the most extreme event. Maximum relative velocity, maximum consequence. James at mid-latitude faces something severe and unprecedented. Sigrid, near the poles, watches from her window as the world briefly goes wrong and then struggles to right itself. Same planet, same 5 seconds, 3 completely different stories. Whether any of them are there to tell those stories afterward depends on variables the science cannot fully settle. And the oceans, the atmosphere, the geology, all of them respond differently in different places. To the same event, 5 seconds. That is all. But here is what this actually reveals. We think of the ground beneath our feet as the definition of stillness, the stable thing, the constant, the thing that will always simply be there. It is not still. It has never been still. Right now, as you read this, you are moving eastward at somewhere between almost nothing and 1,600 kilometers per hour. Depending on where you live on this planet, everything around you is moving at exactly the same speed. And the reason you cannot feel it, the reason the oceans are not surging, the reason the atmosphere is not tearing across the surface is not because nothing is moving. It is because everything is moving. Together, perfectly, silently, without a single second of interruption for 4.5 billion years. Tomorrow, morning when you step outside and feel that ground solid beneath your feet, you might remember Amara and James and Sigrid, and you might think about the fact that the solidity you are feeling is not stillness. It is everything moving together so perfectly that stopping feels like the impossible thing. If this changed how you think about the ground beneath you, hit that like button right now. Subscribe to the IFs for a brand new mind-bending video every single week. Drop your own. What if in the comments below. We read every single one.